this video, we are going to be introduced to the difference between two kinds of, well, the only two kinds of compound inequalities. Well, what are those two types? They are and or inequalities. So we're going to learn how to graph them out and see just a rough difference of them, just to introduce you to those ideas. The idea of what it means to compound, right, is to put one thing with another, like a compound sentence. I went to the park and I ate ice cream. That would be, I went to the park, I ate ice cream. A compounding of two sentences. We're going to compound inequalities. So it's basically two inequalities put together. We're asked to graph x is greater than 4 and x is less than or equal to 6.5. That's the compound inequality. The word and is the key idea there. We're going to do it on two number lines and then combine those onto one number line. And eventually you'll just be graphing this on one number line. I just want to show you how we get to the one number line. Now the idea of and is that all the solutions for the compounding of x is more than 4 and less than or equal to 6.5 means that any number that's a solution to this must be true in that it's got to be more than 4, but less than or equal to 6.5. So a number like 5 would work because 5 is more than 4 and it is less than or equal to 6.5. So the numbers that work here, the solutions, are true for both inequalities. That's the most important part. And that's what the word and means in the real world. I went to the park and I ate ice cream. That means I did both. Both are true. So like the number 3, while it's not more than 4, it is less than or equal to 6.5. It does not satisfy both inequalities. It would not be a solution. So without further ado, let's graph it out. So x is greater than 4 is not a bad graph to do. We've graphed out many of those, and I'm just going to do a rough graph of it. Let's put 4 right here. And we've got an open circle, and we're going to the right, right? Because we've got all numbers greater than 4. So right underneath it, I'm going to put another number line. And we'll put 6.5 roughly right here. Right, so there's 6.5. It's all numbers less than or equal to 6.5, so we'd do a closed circle there, and then be all numbers to the left, or less than or equal to. Now we want all the numbers that are both more than 4 and less than or equal to 6.5. Well, that would be numbers that fall right in here. Those would be the numbers that are more than 4, but are less than or equal to 6.5. So imagine taking those two graphs and overlaying them. And so what we end up with is a little interval here. So 4 to 6.5. And the overlay of the two would be this space right here. So you'd still have an open circle at 4, shading up to 6.5 and including 6.5. Those would be all numbers that satisfy this and this. So we don't want anything out here because those aren't numbers that satisfy that graph, and anything above 6.5, well, though it satisfies the greater than 4, doesn't satisfy the second one. It's got to be true in both graphs. So it's the overlay of them and all numbers in between. Very cool stuff. Okay, so, one other thing. You might notice too how the endpoints that we have here match our understanding of greater than with no or equal to is an open circle, as in the past, and or equal to is a closed circle because we're including that number. Okay, so we're going to do a similar exercise, but now the key word here is or. So in an or inequality, that's a little bit of a different meaning. If I said I went to the park today, either I went to the park or I ate ice cream, that means that I did one or the other. I could have done both, but I didn't have to do both, right? I either did this or I did that. It could be one or the other, and both could be true also. So what that means is solutions to an or compound inequality just need to work for one of the inequalities, not necessarily for both. So if I pick a value like -1, that works because it is less than or equal to 2, even though it's not greater than or equal to 5. It's true for this one, and that's fine. That satisfies or. Or we can pick a number like 72, which is more than or equal to 5. Even though it's not less than or equal to 2, it satisfies the more than or equal to 5. So with or, the solutions satisfy one or the other inequality, and our graphs reflect that. It's not going to be an overlap. So we're going to do the same activity. I'm going to graph x is less than or equal to 2. So I'll put 2 here, and a closed circle and all values to the left using our inequality shading skills. Then I'm going to put another inequality directly below it on another graph, and we want the values greater than or equal to 5. Okay, so let's put 5 here. So or equal to, so closed circle and shading to the right. Beautiful. So now our solutions either fit this or this shading. So both shadings should be included in our final answer. And that's why I'm going to have both the 2 and the 5, and there's not going to be necessarily overlap here. So I include both shadings and don't look for an overlap. So any number less than or equal to 2 or greater than or equal to 5 works and makes this inequality true, and that's why our graph contains both graphs. Very cool stuff. Now, a little point in case you're looking for challenge here. If this word were and, there are no numbers that are less than or equal to 2 and greater than or equal to 5, right? That would be, well, looking at numbers that are less than or equal to 2 and greater than or equal to 5, there's no number that we know of, so there'd be no solution to that. So or means either one direction or the other, right? Either one inequality or the other works, and means it works for both inequalities. You're looking for the overlap. Super cool. See you in the next video.